Hi Logic students, this is a video to introduce chapter 6 in Hurley's A Concise Introduction to Logic. The theme of the chapter is symbolization, and basically symbolization is to rewrite something in an abbreviated form, in a form that makes it easier to see what the structure of the original is. So I would say the purpose of symbolization is to see more clearly into the structure of statements and arguments. This is something that is very important in logic for a reason that we can see through an example. Look at these two arguments. If it rains, Bob always brings his umbrella. It is raining, therefore Bob brings his umbrella. And if x is greater than 10, then x is greater than 5. X is greater than 10, therefore x is greater than 5. I think you can probably see that, well, both of these arguments are valid, but you know by now that an argument is not valid when it is valid because of what it talks about. It's valid when it's valid because of its structure, because of what lies underneath the content, so to speak. So this argument is not valid because it talks about a person by the name of Bob and his umbrella and rain. It's valid because it makes the claim that something, that is rain, is sufficient for something else, for Bob bringing his umbrella. And then it says that, and that's something that happens in the second premise, it says that the sufficient condition is actually met. It's actually satisfied. So the other thing follows from this. And this is exactly the same thing that's going on down here. This other argument, again, is valid, but not because it talks about certain mathematical facts. It's valid because it says that x being greater than 10 is a sufficient condition for x being greater than 5. And then, as it happens, this particular number x is greater than 10, so the sufficient condition is met. And so the consequence, x is greater than 5, does follow. I think you can see that these two arguments have the same structure, and this can be seen even better if we try to get rid of English. If we try to get rid of the content that is formulated in English, and we just rewrite these arguments with capital letters in place of the statements. So instead of writing it rains, we could just simply say R. And instead of writing Bob always brings his umbrella, we could simply say B. So let's do that, and that will exhibit the structure of the argument. This is something that we already tried in section 1.5, actually. So let's say that it rains or it's raining will be symbolized as R. So let's put it in. And Bob brings his umbrella will be B. So if R, then B. And here, therefore, B. So we got rid of a lot of words, and now we can see a little bit more clearly what the structure is. If R, then B, R, therefore B. Now we can do the same here. We're going to let, let's say, G stand for x is greater than 10. And then we're going to let F stand for x is greater than 5. It's easy now to see that the two arguments have the same structure, right? You have a conditional, and then the second premise is the antecedent of the conditional, and what is inferred is the consequent. Again, a conditional, the antecedent, and the consequent is inferred. So now we can see what the structure of the two arguments are. We haven't gotten rid of all English, though. And there is a way to do that. Actually, you want to use a language that is completely symbolic. So in order to get rid of English completely, you want to introduce symbols, not just for statements of the English language. Look at what we did earlier. We replaced "it rains" with the letter R, but also for these expressions like if, then, expressions that don't really have a meaning themselves, but can serve to connect different statements, expressions that in logic are called connectives. So the main connectives you can see in this list, and obviously they are in the book as well. To modify a statement, you can use the word not, and to connect together different statements, you can use words like and, or, if, then, as in the examples that we just looked at, and also the expression if and only if. So in chapter 6, we introduce symbols for these logical connectives. That's the way they're called, or logical operators. I think that's the term that our textbook uses, operators. For statements, we're just going to use the capital letters of the English alphabet, A, B, C, D, etc. And you just pick whatever letter is convenient, or whatever letter you prefer. For not, we're going to use a symbol that is known as the tilde. It's a symbol some of you may be familiar with. It's used in Spanish, and it's basically this symbol here. It looks a bit like a wave, and you can get it from the keyboard as well. So in the keyboard, you'll be able to generate that symbol. For and, we're going to use a dot. So all you do is really just to draw kind of a thick dot. It's hard to do with this pen, but just imagine a bullet point, something like that. Maybe I'll show you how to draw the symbols, and then we'll look at what to do on the keyboard. For or, you use a symbol that is called the wedge. It looks like a lowercase v. For if, then, you use a symbol called the horseshoe. For obvious reasons, it looks like a horseshoe. And for if and only if, there's a symbol that is called the triple bar, again, for obvious reasons. These are all the symbols that you use in this language. It's very simple, really. It's not a large number of symbols that you'll be using. The capital letters of the English alphabet, these symbols for the logical operators, and then parentheses, and if necessary, brackets and braces. These are the only symbols that you'll be using. In the keyboard, what you can do is, because you'll be typing, and obviously you wouldn't be able to draw in our class forums, and it would be too difficult to do that. You can simply use some substitutes. From the keyboard, you can get the asterisk to do and. You can do the lowercase v easily, of course. So you can use that for the wedge. For the horseshoe, you can use this symbol, which is in your keyboard. And for if and only if, you can just use the equals sign, which is also, this one that is accessible from the keyboard. And then obviously the parentheses you can get from the keyboard as well. Okay, so let's see how this is supposed to work. Let's do some examples of symbolization. Okay, so if you have just a single statement, such as life is beautiful, it's very easy to symbolize. All you have to do is just use a single letter. In this case, I guess you can pick L. or life is beautiful. You don't have to pick L. You could pick whatever letter as long as you stipulate that it's going to mean life is beautiful. So if you decide that A means life is beautiful, then your symbolization will be A. If you want to say Danny DeVito is not tall, what you do is you pick a symbol for Danny DeVito is tall. So let that be D. And then you place a tilde in front of it. So that's Danny DeVito is not tall. If you want to say roses are red and violets are blue, obviously the main logical operator is and. So you draw the dot, you put it in the middle, and then you choose a symbol for roses are red. I suppose R will do. And you choose a symbol for violets are blue, V. So R and V would be roses are red and violets are blue. This other statement is an either or statement. So you'll be using the wedge, a lowercase v. You can just draw it. And then the either part is you study hard. The or part is you will not get an A. So let's be careful here. You study hard can be symbolized as S. And on the other side, there is you will not get an A. So we have to say something like not A, where A means you will get an A. So tilde A means you will not get an A. Here's a conditional. If three, I'm sorry, that is missing a word. If three, oh no, that's fine. If three more people, I thought it was if three or more people, but no, if three more people sign up, that is fine. So if three more people sign up, we'll have a team. T stands for three more people sign up. So if T, then we'll have a team. You have to pick a different letter. You cannot let T stand for three more people sign up and also we'll have a team. So let's say H in this case. Notice that sometimes you will have to group things together with parentheses. If three more people sign up and pay the fee, we'll have a team. So here the antecedent of this conditional is three more people sign up. Three more people sign up and pay the fee. If that happens, so let's keep it together, then we'll have a team. So notice how you use the parentheses to group things properly. A geometrical figure is a triangle if and only if it has three sides and three angles. So a geometrical figure is a triangle if and only if it has three sides and three angles. Letting T stand for a geometrical figure is a triangle, S stand for a geometrical figure has three sides, and A stand for a geometrical figure has three angles. So now you can see this last example is a little bit more complicated. So why don't you try it on your own, and then in a subsequent video, I'll go over the solution with you.